We're going to look at frequency distributions, statistical charts, and graphs. When looking at a large number of data points, it is often useful to organize the data into a chart, a table, or a graph. A frequency distribution organizes the data points and the frequency with which they occur. Here's an example. A class was surveyed to find out how many classes each student is taking this semester. The results are listed below. So as you can see, I have a lot of numbers. Basically, they're 1s, 2s, 3s, and 4s, but they're not organized in any way that you get any meaningful result out of looking at the data points separately. But if I take the time to put them into a frequency distribution, I can see that the number of classes that were represented, students either were taking 1, 2, 3, or 4 classes, and then the frequency is I had 11 people taking 1 class, I had 8 people taking 2 classes, there were 7 students taking 3 classes, and then 4 students taking 4 classes. So this distribution organizes the data into a way it's meaningful for us to look at it. A relative frequency distribution finds the percent of the sample that each data point represents. So to find the relative frequency distribution, you divide the frequency of the data by the total number in the distribution and then multiply by 100. So our distribution we just had with the students and the number of classes, there were a total of 30 students. So the 11 people taking 1 class represent 11 over 30 times 100, which is 36.7%. The 8 people out of 30 taking 2 classes makes 8 over 30 times 100, which is 26.7%. The 7 people taking 3 classes represent 7 over 30 times 100, which is 23.3%. And then the last 4 taking 4 classes is 4 over 30 times 100, which is 13.3%. So just like when we talked about probability that a sample space needs to add up to 100%, when we talk about a frequency distribution, it should also add up to 100%. Sometimes it's helpful to, instead of looking at a frequency distribution, to look at a chart or a histogram. A histogram gives data along with the horizontal axis and the frequency on the vertical axis. Histograms are typically referred to as bar charts. These may seem very familiar to you, just the name sounds a little different. So in the chart that we're looking at, which is about the number of classes, this uses the data we were doing earlier with students taking 1, 2, 3, or 4 classes. But looking at it as a chart, I can immediately see that 1 has the highest column and is the most frequent thing to happen. I can see 4 has the smallest column and is the least frequent thing to happen. I took the same information and I turned it into a line chart. So a line chart is called a frequency polygon. Again, it just takes the outcomes. So I can see that 11 people took 1 class. I can see 8 people took 2. 7 people took 3, and 4 people took 4. So it's still that same data that I've been doing for all of these examples. It just changes the way it's represented. And then the points are joined together by line segments. If we wanted, we could also represent this data as a pie chart. So in the pie chart, it turns it into percentages. Here, this one's color coordinated. So students taking 1 class was 37%. I can see people taking 2 was 27. I can see people taking 3 was 23. And lastly, 4 people was 13%. Still all the same data information, just different ways to describe it. So we did a frequency distribution, which is just raw data. The second one, relative frequency, that went into percentages. Then we looked at a histogram, a frequency polygon, and a pie chart, but all the same data. So let's just pick some different data. So let's say we had a real estate sales that we were trying to track over the first half of a year. So I put in months of January, February, March, April, May, and June. And I said these were the sales in thousands for those months. So January had 500,000. February had 2,500. Again, this is in thousands. Then I had 8,500 for March. I had 18,500 in April. May has 22,850, and then June had 13,500. Again, all in thousands, but that saves us time in what we have to write. So I took this information and I turned it into a histogram. So you can see in the picture beside it that this just really gives us a way to look at the data, and we can see the highest one was in May. So May had the biggest sales, and you can definitely see that January had the smallest sales, but it is still the same data. It's just a different way of representing it and showing it. And remember, statistics is that it's not just the collecting the data, but also the organization. So this organization was thrown into a chart. So I took the same data and I turned it into a frequency polygon. And in here, this time, the line really shows that increase over time, that from January, as I went through May, that sales were increasing. And I think that really is important when I'm looking at something like that's timely, to say that I can see this as an increase, that it was going up and it hit May and it started to go down. So different types of charts lend themselves better to different kinds of data. Let's also talk about group data. So we didn't have a lot of data yet, but let's make it bigger. When there are a large number of data outcomes, data is often grouped into classes. Common rules for grouping data are you shouldn't have more than 5 to 12 data classes. So somewhere between 5 and 12 should cover all the data that we're talking about. All the data points can only belong to one class. All data classes should be the same width. And then the data classes should not overlap. So let's take a minute to say, like, well, what does that really look like? What is a data class? So let me give you a bunch of data. So these are weights of football players. I did go online and I went to an NFL team and I grabbed all the weights of the football players, because what do I know about weights of football players? And then I did put them in order to kind of really help us talk about this. So I can see the lightest person on this particular football team was 175 pounds. And then the heaviest player on the team was 338 pounds. I will be honest, this is the Tampa Bay Buccaneers. It's probably from a year or two ago, though. I haven't updated it lately and everybody's on break anyway. But I'm from Tampa, so go Bucs. So this is the team I grabbed. So from here, I want just to do some organization to say this is a lot of data points. Like I have one person at 175, I have two people at 185, one at 187, two at 190, right? So I'm not going to do these individual little things like I did about how many classes somebody's taking. So instead, I need to cover from 175 all the way up to 338, and I need to do it in a pretty way. So what I decided to do was to turn it into this chart. So what you can see is 175 to 338 is a range of 163. So I went to, let's make 8 data classes. When I made the data classes, I thought, let's do it in some way that looks pretty. So you can see here I would do 175 to 195, 196 to 216. So these numbers are always 20 apart. So as you're doing them, wherever I leave off, I pick up. So 175 to 195 means I pick up at 196. I add 20, I'm at 216, so the next one will start at 217. So I kept doing this all the way down, right? I kept adding 20 to my class. So this 320 ends at 321, and I got to make sure I represent that guy weighing 338. I add 20, it's 341. That's where I stop. So I have the lightest player up to the heaviest player. And then I went back and I just kind of counted and I said how many people are in each of these groups. In the real world, use technology, right? It's easy because I ordered it to kind of count it, but there are capabilities in Excel for it to take these and grab the bit, they would call it bins, to throw it into these data ranges. But you do want to make sure all the ranges are the same. See how these are always 20? That's going to be important. There is a weird question that you're going to get in the homework, and let's make sure we cover it. And the question is going to be, how big is this? What's the width? And I know you want to say 20 because I keep saying add 20, but there's this weird thing that it's really 21. If you were to try to count the 175 to 195, you need to do 195 minus 175 is 20, but then you have to add 1. Let's do something easier to see. Why is it add 1? Say it was 3 to 5. If it was 3 to 5, right, as my data class, I would go 5 minus 3 is equal to 2. But really write out what is 3 to 5. It's numbers 3, 4, and 5, which I can clearly see is 3 numbers. So be careful anytime they're asking you the width of a class. Do the subtraction. That's exactly right, but you need to add 1. Kind of what happens is like this 3, 4, 5. When I do 5 minus 3, it tells me, hey, there's 2 more numbers coming, but it forgot to add the first one. So the 195 minus 175 counted everything after 175, but it didn't count 175, so I would have to add 1. So all of these classes have a width of 21. Super careful with that because it's easy to miss. All right. So here's my data. Here's my frequency. I can see a lot of things about players now. I can see it's not really often that these players were 321 to 341 pounds. I can see it was really common for them to be 217 to 237. So now this data is organized and I can talk about it a lot better. Sometimes the better is, let's talk about relative frequency. So I did the same thing. First thing I need to do most when I'm looking at frequency is if I'm not told the total, let's go find the total. So I added this together and I got 86, which is a lot of players. It makes me wonder, I must have been going like preseason before they got rid of some players, if I took that from the books. And then I divided by the total. So 11 over 86, 18 over 86, right? I kept going down. 21 over 86, 9 over 86. So I went through each of the categories. I divided by 86 to get the relative frequencies, which again should add up to 100. If it comes up a little bit over, that usually has something to do with the rounding, or if it comes up a little lower, it has something to do with the rounding. That's okay. That just says we rounded, but it gives us an idea of what's happening. I think we tend to like percents better than we like raw data. So just knowing 11, what does 11 mean? Oh, that's 12%. That's interesting. So here's our frequency, our relative frequency distribution. All right. There will be questions about the modal class. Modal just means what's most frequent. So when I'm looking at the modal class, I could look percentage-wise and see what has the highest percent. I could look numbers-wise and I can see which number happens the most. In this particular case with the weights of football players, I can see 21 is the highest number. So the answer to the modal class would be 217 to 237 because you want to answer with the class, not with how often did it happen. So I also made this one about gas prices. So I have this data. It represents gas prices for a gallon of premium gasoline at 20 different stations. This was a particular time. You know, the gas prices changed, and right now they're a little bit lower. But at this particular time, this is what I grabbed from 20 things just by going online. So again, the data is all over the place, and the data being all over the place is really hard to look at and to decide what do I feel like is represented here. So we're going to change this, and we're going to kind of group the data. So I grouped the data into classes again. So I started at 225 and I went up to 249. So this time you can see I added 4 every time. So this is a class width of 5 cents. So from here to here. So again, thinking I subtract and add 1. So this is 5 cents, this is 5 cents, this is 5 cents. So every time I was just adding 4 to get there. Then I go back and I look, okay, how often did that happen? So 4 times it was 225 to 229, 4 times it was 230 to 234, 6 times it was 235 up to 239, 4 times 240 to 244, and then 2 times 245 to 249. So there were 20 gas stations altogether. And then I just quickly turned that into a graph. And you can see I made a histogram or a bar chart that shows you the different frequencies, and I can see how often they happen just by looking at the chart. So same data, just a different way, of representing the data. Again, I think the charts are easier to read sometimes than looking at a bunch of numbers, even though they have the exact same information in there. All right, so looking at this group data that I've given so far, say I went to more of them and I wanted to say like, let's add another group to it. So what would be the next data set, right? The next class of data. And then I also want to know what's the modal class for this data. So take a second and look at it. Shouldn't take you too long. You can pause me if you need to. And then come back and let's just go over these 2 questions. So for the first question, what would be the next class B? Well, we would pick up at 249 and we would go to 250. Notice that we're always, if you look, it's always adding 4. So this would go 250. Oops, my pen didn't do so awesome there. To 254. So that's supposed to say 250 to 254. The modal class says what happened the most. Well, 6 is the highest number, and that represents 235 to 239. Yep, and there's the written pretty. Here's a problem that we have when we have group data, if we don't have the original numbers to go with it. I can't tell what the smallest and the largest value of the data actually is. So say I only gave you this group data, or I gave you this frequency distribution, but I never told you the actual data points. So I couldn't really tell you what was the smallest price of gas. I could guess that it was 225, but I could be wrong, right? It could be 226 or 227. It's something in that first data class. And I can't tell you what the largest number in the data class is either. So there is that little issue with group data that we lose a little bit of information, and maybe we're fine with that. But it's just something to think about when we're looking at statistics. So I want to show you another way we can view data, and this is called a stem and leaf display. So these are the same data points that I had earlier, but all I did was organize them a little differently. So to start, to do the stem, I'm saying, okay, what major theme is going on here? All of these gas prices were in the $2 range. And then I can see that some were in the 220s, I had some in the 230s, I have some in the 240s, but that's all I see. So I first kind of skim through and look for some overlying themes to the data, and that's where I start, and that's my beginning that I make my stem from. So once I go, things are in 220s, 230s, and 240s, then I start building the leaf. So the leaf is, for this case, the cent part. So you can see the 7 is this 7 here, and this 31 is this 1 over here. And I went through every data point, and it's represented in this stem and leaf display. If a number happens twice, like 235 happens here and here, and that's the only time, you'll see it twice in the stem and leaf. You want the frequency to be represented here. What I can tell you though now, by looking at the stem and leaf, that 227 was the lowest price for gas. 247 was the highest price for gas. I haven't lost any of the data, and I can tell you there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, I might have counted wrong. There's supposed to be 20 there. I can tell you all the gas stations that I went to, right? So this stem and leaf display is a nice way to look at data. I don't think it's a very frequent thing that you'll see except when you take statistics class, but it is another organization for you. So let's look at this stem and leaf display that's about a basketball team. And what I did was I broke up their heights based on how many feet and how many inches. So when I'm looking at this, the stem is the feet and the leaf is the inches, and I can look for what's the height of the smallest player on the team. So the smallest player I can see would be 5 foot 10 inches. So I can write in 5 foot 10 inches. And then the tallest player on the team, so I look, here's my 7, 2, so it would be 7 foot 2 inches. And then how many players are on the team? I just add up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have a total of 15 players, which is what this one will say too. It's written a little nicer in case you want to see it typed instead of in my handwriting. One last thing we want to look at again is a pie chart. So we looked at a pie chart quickly earlier. Let's look at it again. If you can't see this number, this one is 22%. It didn't show up well. All right, so what I had this do is this shows a survey where it asked people what's your favorite car color, and then it broke up the answers into percentages. I'll tell you, I made up these numbers. These aren't factual. They're just numbers that I put in there, and I put this into Excel. And what's interesting in Excel is when I highlight the stuff and I say, please make me a chart, it's a computer, not a person, and it can't really read. So sometimes it works out nicely, like this thing that says white matches white, black matches black. But notice this next one that says red is actually silver, and the one that's silver is actually red. So super duper important that when you're reading pie charts or any kind of charts, don't assume that the color that is shown represents the color that the question asks for, because when you're having a computer do something for you, it's kind of up to you if you go back and edit it or if you just leave it the way it is. So I don't always edit it, because that is that critical thinking part where I want you to read. So be careful, slow down. I'm not trying to mislead you. I'm trying to just do something simple, which is have Excel do my charts for me and me not have to edit it later. So take the time to read it. So first question says, what percent of people like silver or gray or silver? So I make myself go to the bottom to the key, and it says gray is this color. this is gray. And then it says silver is actually this color. This is silver. So I have 14 and 13, which is 27%. Then the next question says, what percent don't prefer black? Okay, so I want you thinking complement rule. We've talked about complement rule before. It would be what else? So if they don't like black, they like one of these other colors. You could add them up, but that's a lot of work. So why not just say, I know the total is 100. I can subtract 19% and say 81% didn't pick black as their first choice. And then the last question says, what's most preferred? So I'm looking through the numbers. I look for the highest percentage, which is 22, and that corresponds to white. Right. So I'm not going to have you make any charts. I just want you to read charts to be able to go through and pick out the information. I do want you to slow down and make sure you read things, but these shouldn't be difficult.